Hi! So for today's video, we're going to discuss about the analytical chemistry problem solving. So if you're watching this, please get ready your scientific calculator and periodic table. Analytical chemistry solving problem number 1. Letter A. Calculate the pH of the solution that is 0.100 m methylamine NH2CH3 and 0.400 m of sodium methylamine. Solution. CmCH3 in H2 or molar concentration of CH3 in H2 or the methylamine is 0.1 m. CH3 in H2 plus H2O is equals to CH2 NH3 positive plus OH negative. This is the balance equation for this reaction. 1 mole is equals to X, that is equal to 0.1 m OH negative. Methylamine CH3 in H2 is a weak base that reacts with water according to above equation. For this reaction, at equilibrium, the Kb is equal to 4.4 times 10 to the power of negative 4. Then find the molar concentration of OH negative by multiplying 0.1 times 4.4 times 10 to the power of negative 4. That gives us 4.4 times 10 to the power of negative 6. From this result, we can now calculate the POH. POH is equals to negative log OH negative. Our OH negative is 4.4 times 10 to the power of negative 6. And that is equal to 5.36, that is the POH. Now, to find the pH, subtract 14 minus POH. 14 minus 5.36 is equals to 8.64. pH is equals to 8.64. Then, let's proceed to letter B. Calculate the pH change when 80 ml of 0.15 KOH is added to the 100 ml solution stated above. First is find the mole for CH3 in H2 by multiplying Cm times volume is equals to Cm 0.1 times V of 0.1 equals 0.01 mole. Then calculate the mole for CH3 in H in A, the same from the first equation. Multiply the Cm and volume, that is 0.4 times 0.1 is equals to 0.04 mole. And mole for KOH is equals to 0.15 times 0.08 is equals to 0.012 mole. The balance equation for this is CH3 in H2 plus KOH is equals to CH3 in HK plus H2O. 1 mole minus 1 mole KOH. 0.01 mole minus X. And X is equals to 0.01 mole KOH. Then add 0.012 plus 0.01 is equals to 0.002 mole for KOH, and the new volume is 0.01 plus 0.08 is equals to 0.18 L. Cm KOH N divided by the volume, that is 0.002, or N divided by 0.18, the volume, and that is equals to 0.1 m. KOH equals K plus positive plus OH negative. 1 mole KOH is equals to 1 mole OH negative. 0.002 m is equals X and equals to 0.002 m OH negative. And for the POH is negative log OH negative is equals to negative log 0.002 is equals to 2.7, and then pH is equals to 14 minus 2.7 is equals to 11.3. Letter C. Calculate the pH change when 80 ml of 0.10 HNO3 is added to the 100 ml solution stated above. And CH3 in H2 is equals Cm times volume, that is 0.1 times 0.1 is equals 0.01 mole. And for CH3 NHNA is equals Cm times volume is equals 0.4 times 0.1 is equals 0.04 mole. NHNO3 is equals Cm times volume is equals 0.1 times volume of HNO3 is 0.08 is equals 0.008 mole. Balance equation for this reaction is CH3NHNA plus HNO3 is equals CH3NH2 plus NaNO3 1 mole minus 1 mole of HNO3 minus 1 mole CH3NH2 X minus 0.008 mole minus Y, and X is equals 0.008 mole CH3NHNA and Y is 0.008 mole CH3NH2. And CH3NH2 is equals 0.01 plus 0.008 is equals 0.018 mole. And the new volume is 0.1 plus 0.08 is equals 0.18 L. Cm CH3NH2 is equals N divided by the volume, that is 0.018 divided 0.18 is equals 0.1. And for N CH3NHNA is equals 0.04 minus 0.008 is equals 0.032 mole. And the new volume of CH3NH2 is equals 0.1 plus 0.08 is equals 0.18 L. Next, find the M for CH3NHNA is equals N divided by volume, that is 0.032 divided 0.18 is equals 0.178 M. Balance equation for this reaction is CH3NH2 plus H2O is equals CH3NH3 positive plus 0 plus OH negative. 1 mole CH3NH2 is equals 1 mole OH negative. 0.1 M is equals X and equals 0.1 M OH negative. Methylamine CH3NH2 is a weak base that reacts with water according to the equation above. For this reaction at equilibrium, the Kb is 4.4 times 10 to the power of negative 4. Cm OH negative is equals 0.1 times 4.4 times 10 to the power of negative 4 is equal to 4.4 times 10 to the power of negative 6. From this, we can now find pOH. pOH is equals negative log OH negative is equals negative log 4.4 times 10 to the power of negative 6 is equals 5.36. And pH is 14 minus 5.36 is equals 8.64. Let's proceed to the number 2. Describe or explain and draw the titration of curve of the weak acid versus weak base. Weak acid. This is a sharp increased pH at the beginning of the titration because the anion of the weak acid becomes a common ion that reduces the ionization of the acid. After the sharp increase at the beginning of the titration, the curve only changes gradually. Weak base. In a weak base titration, the acid and the base will react to form an acidic solution. A conjugate acid will be produced during the titration, which then reacts with water to form hydrogen ions. This results in a solution with pH lower than 7.